morning, students. So we are going to discuss one more lecture series on use of hybrid energy. So hybrid energy basically refers to a system that combines multiple energy sources such as fossil fuels, renewables, and to enhance efficiency and reliability. They basically balance intermittent sources like solar and wind with consistent ones like diesel and generators. So basically the combination of renewable and non-renewable resources in such a way that it will be sustained for future use also, that will be part of this chapter. So use of hybrid energy, with the advent of hybrid energy systems marking a transformative era in an approach to powering the modern world. Basically, by combining the reliability of conventional energy sources with renewable energy innovations, we are embarking on a journey towards enhanced efficiency and sustainability. You know, students, that sustainability is the need of the hour. It is basically utilizing the resources in such a way that they are optimum utilized and they are preserved for future use also. So basically the hybrid energy can be utilized in power plants. The hybrid energy can be utilized in vehicles. Those vehicles are referred to as hybrid energy vehicles or HEV vehicles in abbreviated form. Hybrid energy can be used in agriculture also. So we will quickly see these aspects of hybrid energy. So as I was talking, hybrid energy can be utilized in vehicles, it can be used in power plants, it can be used for agricultural purposes also. So in transportations, the integration of hybrid technology into transportation manifests in reduced emissions and heightened fuel efficiency. So the target is basically to reduce the emission of fumes, okay, reduce the emission of vehicular pollution and increase the fuel efficiency. In case of power plants also, basically it focuses on capitalizing on renewable resources during the peak availability and demand for unwavering foundation sustainability. Then by synergizing renewable system with existing energy infrastructure industries, it can dramatically lower carbon footprints, that is the emission of carbon dioxide. You know, developed countries are putting pressure on developing countries to reduce the amount of carbon dioxide generation, because you know, students, carbon dioxide is a prominent source of emission of or capturing of immense heat from the sun, global warming, because carbon dioxide is a prominent greenhouse gas, right? So hybrid power plants. So basically hybrid power plants ingeniously merge solar energy with fossil fuels, creating a dynamic duo that leverages sun's bounty and steadfastness of traditional plants to provide a consistent energy supply. So in case of wind and gas turbines, solar and fossil fuels, hybrid energy has to be utilized. In case of vehicles, basically hybrid energy systems in vehicle combine internal combustion engines, which is known as ICE, with the electric motors to enhance fuel efficiency and reduce emissions. These vehicles are known as hybrid energy or hybrid electric vehicles, HEVs, and they utilize both power sources in various configurations. So there are series hybrids, there are parallel hybrids. Hybrid vehicle benefit from regenerative braking, when the electric motors help to sow the vehicles and recover energy to recharge battery. So these systems reduce fuel consumption. The basic target is to reduce the fuel consumption, increase the efficiency of fuel, also to reduce or minimize the amount of production of fumes, the vehicular emissions, the gases emissions from the fuels. So these systems reduce fuel consumption, lower emissions, and provide a smoother driving experience, contributing to a more sustainable transportation. So waste heat recovery in gas turbines in case of power plants. So heat generation, as gas turbines spin their mighty blades, they generate not only a powerful but a significant amount of waste heat, and untapped that heat is released into the atmosphere, okay, and disturbs the ecosystem. The ingenuity of modern systems allows for salvage of this waste heat, repurposing energy that would otherwise dissipate unnoticed into the atmosphere. And the comprehensive use of waste heat exemplifies our capacity to magnify efficiency, elevating the functionality of gas turbines to realms of energy virtuosity. So energy storage in power plants. So excessive energy has to be stored, okay. So energy storage system embody the prudence of saving for a rainy day, capturing the abundance of power in tranquil times to bolster the grid's vitality when thirst for energy peaks. During the energy crisis, when there are power cuts, okay, when there is a huge demand of energy, then those stored energy can be utilized, okay. During the peak demands, as the demand amplifies, these storage discharge their reserve, ensuring a tumult of energy needs meets a steady, unflinching supply. So renewable integration. Microgrids demonstrate the artful integration of renewable sources with conventional generators, framing a future where power is as much balanced as it is about generation, stability and reliability. The embrace of energy storage with this self-sufficient ecosystem speaks to an assurance of stability, with batteries serving as the custodians of continuity. Then solar wind hybrid system. This is very unique concept, okay, combining the solar and wind power in off-grid locations to maximize energy production throughout different weather conditions and times of the day. Then integrating various renewable energy sources such as solar, wind and biomass with energy storage system to provide reliable power in remote or isolated areas. Then one important aspect is utilization of hybrid energy in case of agriculture. So in case of agriculture, agricultural applications of hybrid energy system often include combining solar panels, wind turbines and bioenergy to power irrigation, heating and cooling systems. This integration supports sustainable farming by reducing reliance on fossil fuels, cutting energy costs and ensuring a reliable energy supply for continuous agricultural operations even in remote areas. Then desalination. Desalination basically refers to curtailing the salinity, okay. So integrating solar panel with desalination process to produce fresh water from seawater. You know, the seawater contains salinity as much high as 97%, okay. So reduction of the salinity will help in converting the unusable saline seawater into usable potable water or drinking water, right? So particularly in regions with abundant sunlight and limited freshwater resources, this will be very useful. Then wind driven desalination, utilizing the wind energy to power desalination plants, providing an alternative to conventional energy sources in coastal regions. Mining and explorations. So the solar, wind and other renewable sources of energy can be combined with conventional powers to reduce reliance on diesel generators in remote mining operations. Incorporating hybrid power systems in exploration vehicles to increase energy efficiency and reduce environmental impact during resource exploration, okay. Then emerging technologies, you must have seen and noticed the word IoT, Internet of Things, which is very popular now, right? These days, artificial intelligence, machine learning, Internet of Things, these are very famous. So implementing hybrid energy solutions for powering IoT devices and sensors, combining energy harvesting techniques with small scale energy storage. Then hybrid power in space exploration, which is very interesting. So integrating solar panels with advanced energy storage systems for spacecraft and satellites to extend mission during means power backup, okay, and extracting energy from those things to supply for the space exploration missions, right? Then environmental monitoring, off-grid monitoring stations using hybrid energy systems to power remote environmental monitoring stations combining solar, wind or other renewable sources with energy storage. Integrating hybrid energy solutions into platforms for collecting and transmitting environmental data, ensuring continuous operation in remote and challenging environments. So we'll end this lecture with this very famous quote, okay. In non-conventional applications, hybrid energy systems play a crucial role in providing reliable and sustainable power solutions, addressing the unique challenges of off-grid, remote and mobile environments. These applications contribute to increased energy resilience, reduced reliance on traditional fuels and a lower environmental footprint. So we'll continue with more lectures in our next class. So that's all for today. Thank you so much. Have a good day. Bye.